What's up, everybody? Welcome to Earth Science, Lake Ontario Depth Lab. So let's look at it. What are we trying to do here? The goal is that rather than do topographic maps, which show like elevations and all of that, right? Hills, valleys. This is the same exact thing, only it's going to be with the depth of Lake Ontario. So rather than like going up over a hill, it'll be going down to the bottom of the lake and back up. Okay. Um, it's going to have to be pencil and paper for this lab because of all of this you got to do. You just can't do these things on a computer screen. So I think the best strategy here is to watch this whole video. I'm going to make it as fast as I can, then get out the pencil and paper, work your way through. And if something pops up, you don't know how to do it, just pop back to the video and we'll get this thing going. Okay. So yeah, this is your map. The very outside line would have a value of 0 because that's the shoreline. If you go over there, which I guess I would write that over here, right? If we were in Pulaski, if you went over there towards Port Ontario and stood on the shoreline, the water is 0 feet deep. And then as you go out into the water, it gets deeper and deeper and deeper and deeper. If you can't figure it out here, what's the contour interval? What does it look like it's going by? Hopefully you got it. 100. And these are in feet. This term, I'm not really concerned about it. If you want to skip this blank, I won't penalize you for it. Isobaths. It's lines or contour lines. It's lines for how deep the water is. Don't stress that. What's the depth of the shoreline? Like we just said, that is going to be 0 feet. Okay. Chuck those on there when you get a minute when you're ready. But again, I think it's going to be best if we talk about this whole thing first and then get it moving. So do all the questions. Sometimes people like skipping these couple of questions. Look at the lines. What do you notice about the spacing? Keeping in mind, what's the deal with spacing and steepness? So how steep is the floor of Lake Ontario as you go down? What does this mean about the gradients? That's what we're all going to figure out, right? So we're going to draw profiles. Now listen, if you haven't done, you shouldn't be here at all if you haven't done the profiles and the gradients, those worksheets that are right over there by the green chalkboard. If you haven't made it through that stuff yet in the quiz, you really shouldn't be looking at this video yet. You would have no idea what's going on. This is going to be where you show me you really do. So it's going to have you go from A to B. And again, this is why we need paper. You can't like lay that thing on a computer screen and make the marks. It's just not going to work. But do keep in mind A to B. We want A on this side and B on this side. Same thing here, C to D. We want C on this side and D on this side. Because what we're going to end up doing is comparing where is it steeper versus where is it more gradual. And if you're starting to get topo maps down, that should be a little on the obvious side. Is it steeper over here near B or steeper over here near A? Okay. To make that all make sense, you've got to plot A to B correctly from left to right here. Now, if you did it and you got your piece of paper and you suddenly realize, like, I did it wrong, all you got to do is take a piece of paper and flip it over, and then it will work. It'll still be the same. You don't have to redo your work. But do please make sure that it's that way. Also, please don't tell me that the lake on bottom of Lake Ontario is shaped like this. This would not hold water, right? That didn't work. Roughly, the bottom of Lake Ontario is going to look like this so that water can be held in that basin, okay? Way more precise than that. I'm just throwing that out there for information. So the way that we'll label these is that the very top line up here, that's 0 feet. And then all you got to do is go down by 100s. I'm not going to do all of those right now because you folks are going to be good at that on your own. Let's go down by hundreds. 0, 100, 200, 300. If you'd rather do it on that side, do it on that side. Knock yourself out, okay? Label that all the way down. Do the same thing over here, label it all the way down. Yes, this one's a little bit deeper. That's deliberate. And you'll have to do it again. Label it all the way down. Because on this one, you're going to go from E to F, which is, there's E. If the print's a little dark, it's right there. All the way to F. And keep in mind or note that as you do this, you're going to get down into a deep part right there, and then it gets a little shallower, and then you go down to an even deeper part over here, and then it gets a little bit shallower again. Okay? The bottom of Lake Ontario has a couple of deeper sections called basins. Speaking of which, this little blurb right here, in a year where I'm not doing this all on YouTube, I can tell the people that read this and the people that didn't read this from a mile away, okay? Read this. This is going to be how you make it through these gradient problems here and these gradient problems here. In fact, it tells you that we have two major basins at the bottom of Lake Ontario. The basin to the west is called the Mississauga, with a maximum depth around 620 feet. That number right there you need for these problems. The deeper basin to the east, the Rochester one, has a depth of 790. Again, you're going to need that number, okay? Because your gradients problems, first off, gradient formula, you can steal that right off the front page of the Earth Science Reference Table, which you have multiple ways to get to. It's on the all MP1 assignments, or you go to good old Google and you type NYS for New York State, ESRT for Earth Science Reference Table, and there it is. On the very top, one of the 4 equations you need this year is gradient. So steal it from right there, chuck it in there. So what is the gradient from the deepest part of the Mississauga Basin? Well, if I already told you right here that the bottom of it is 620 feet deep, and if we're talking about starting from the shoreline and going down, that means you're going to be going down the difference from 0 to 620, which is 620. The next part is the distance. How far is it? That's where you're going to have to use this map scale right here. These are in miles. And if this is the Mississauga Basin, you're going to have to measure from the shoreline, point B, down to about the middle of that approximately. How many miles is it to get down those 620 feet? How many miles is it to get down those 620 feet? Same deal with the Mississauga. I'm sorry, this is the Rochester one. The Rochester one, which says that it's 790. So these are going to be going down 790 feet. How do we do it from D and C to get down there? We're going to have to just ballpark estimate about where the middle of this is, because that would be the deepest part. It's almost 800 feet. And then measure from D down to the middle part, from C down to the middle part. How far is that with this scale on a little piece of paper? That's your gradient. How much do you go up, down, divided by how much do you go distance-wise. Same thing as slope in math class. All right. I did note, for some reason, the E is missing over here, but this is from E to F. The F is there and the E disappeared somehow. No big deal. Note that, and it's the same as above. These are 0 and going down by 100s. 100, 200, and so on. This one's a little trickier. You're going to have to be careful and really make sure that you follow that line, the rule with the lines, where if there's a dot, you must cross the line. All right, so when you end up with a couple of dots, make sure that you cross like that. It's going to happen. And if you're confused, just let me know, and I'll come on over and we'll get that thing worked out. All right. The rest of it's not too bad. If the top of Lake Ontario, the shoreline of Pulaski, the shoreline of what do you call it over there? The lighthouse, all of that, Port Ontario. If that is about 250 feet above sea level, right here, that means everything below 250 feet is actually, the bottom of this lake is actually lower than sea level, which is kind of weird to think about. It's way down there. So you're going to color all that just using colored pencil or something. And then this is like a basic, include this, make a description. Tell me what this bottom is shaped like. Use some things that you learned, like gradient, the spacing of isolines, to tell me where it's more steep, maybe where it's more gradual, and things like this. And I don't think it'll be too bad. People usually bang through this one pretty easily, provided you've practiced all your gradients and profiles before you got to this. All right, best of luck. Let me know if you have any questions. Double check this video, and don't forget that this reading part is going to help you significantly. Good luck.